Hey, stats people, this is Troop. I'm going to do a quick lesson here, a screencast, and should record this as I do it on my computer. You'll see my mouse here, the cursor, um, in my PowerPoint, which I will use typically in class. This is the part 4 of probability, and this shouldn't take too long to get through. Most of it's a review of what you've seen already the last couple of days, and I'll give you an assignment at the end of this, which will be on Canvas on today's module, and you'll have to download it and then do it on a separate piece of paper. So just a brief review of what we've been doing. We used the addition rule the other day, yesterday, when I was, or the day before, I guess, losing track of days. The addition rule is where we have disjoint events. And this time I use the term, the events E and F this time. Disjoint where you cannot have an outcome occur at the same time on both events. So we talked about those on Monday. And so the disjoint events, we add the probabilities. It's called the addition rule. You add the two probabilities, or three, or whatever it is, probabilities together. So a quick example just to remember what we're doing. Suppose a randomly selected student has a probability of being a sophomore, 0.20. Probability of being a junior, 0.30. What is the probability the selected student is a sophomore or a junior? Remember, the or problems were the ones that you did adding the probabilities. They're disjoint. In other words, you can't be a sophomore and junior at the same time. These are disjoint events. We can add their probabilities. So the probability of being selected, one or the other, is the addition of those two, 0.50. And you can see the notation, probability, sophomore or junior. Just add these up. Piece of cake. Just a quick review. Here's another one that deals with cars before I move on to just reviewing multiplication rule. This is another addition rule problem. A large auto center sells cars made by many different manufacturers. 3 of these are Honda, Nissan, Toyota. Out of all the manufacturers represented at the dealership, suppose that the probability of Honda, that's PH here, probability of Honda is 0.25. Probability of Nissan, 0.18. Probability of Toyota, 0.14. So if we were to randomly pick one car, are these disjoint events? In other words, can you pick a Honda and a Nissan at the same time? Or a Toyota and a Honda at the same time? Are they disjoint? Yes, they are. They are disjoint because you can't have one at the same, both at the same time. It's either a Honda, it's a Nissan, or it's a Toyota. Can't be all of them. So, or 2 of them at the same time. So we can add these together. Probability, Honda or Nissan or Toyota, we add all of these 4 numbers together, we get our probability at that dealer, 0.57. Now, to do the complement of that, I'm just going to put this in here. The complement, remember, was kind of like 1 minus the probability that we found earlier. So the probability of not those is 1 minus 0.57, which is 0.43. That is the complement of the probability that we found up here using addition rule. Okay, another brief review. Multiplication rule was the other situation we had when we were looking at independent events. In other words, one event does not affect the probability of the other one. Independence and disjoint are different things, and I talked about that a couple days ago, where they are not the same thing, disjoint and independence. So when you do have an independent events, such as 2 coins flipping or 2 dice being thrown or whatever, you multiply the probabilities. And we did this again a couple days ago. Quick example, what's the probability of flipping a heads 2 times in a row? Each flip is totally independent, therefore we can use multiply the probabilities. So probability of 2 heads in a row is 0.5 times 0.5, or 1/2 times 1/2, which is 1/4, or 0.25. Okay, basic review. This is what we've seen a couple days ago. One more example of this before I show you the new stuff. A certain brand of light bulbs are defective 5% of the time. You randomly pick a package of 2 such bulbs off the shelf of a store. What's the probability that both bulbs are defective? Can we assume they are independent? Yes, we can. Picking one bulb does not affect the probability of picking another one. It's defective. They're independent of each other. So based on that, we can do the probability of defective and defective. Multiply them, since they are independent of each other. 0.05 times 0.05 is 0.0025. That's pretty good. You're buying light bulbs, you don't want to have a defective one. That's a pretty low percentage of getting one that's bad. Unless you buy the real cheap brands, which I've done too much of, and I end up getting a dud half the time. That's another story. Anyway, so that's the deal. This is what we've been doing. Addition rule and multiplication rule. Now, here comes the new stuff. This shouldn't take too long. Probability of what we call at least one. Probability of at least one. Let me show you some examples of what we're doing here. The probability that at least one outcome happens is 1 minus the probability that no outcomes happen. So it's in a way, it's kind of like using a complement. So let me show you a little more here. The probability of at least one in short form is equal to 1 minus the probability of none. A little more explanation. Show you an example. I'll explain a little more here. We're looking again. It's 1 minus the probability of none to find the probability of at least one. So here we go. Here's an example using the light bulbs again. A certain brand of light bulbs are defective 5% of the time. Already did this problem. You randomly pick a package of 2 such bulbs off the shelf. What's the probability that at least one bulb is defective? Now, based on what I just showed you guys before, we're looking at, if I go back to that thing, probability of at least one is 1 minus the probability that no outcomes happen. Okay, now let's go back to here and I'll put it into perspective for this problem. If we're trying to find at least one bulb that is defective, we need to do 1 minus the probability that the bulbs are not defective. Okay, so let's look at this. What is the probability of a bulb not being defective? We know the percentage up here of a bulb that is defective is 5%. What's the complement of that? 0.95. So there's a 95% chance that you will be picking a non-defective bulb. We need to use that. So in order to do the at least one bulb being defective, we need to do the probability. We need to do 1 minus the probability that it is not defective twice, because we're looking at 2 bulbs, 2 independent light bulbs. They're in the same package, but they're independent of each other. So here's the deal. Probability of at least one bulb being defective is 1 minus 0.95 and 0.95. Where are these numbers coming from? Again, 0.95 is the probability that the bulb is not defective. 0.95 is the complement of this number up here, guys. This is the probability of being defective. This is the probability of not being defective. And since we're picking 2 bulbs, this is how you do this. The probability of at least one bulb being a problem is 1 minus the probability of it not being a problem for 2 bulbs. I hope you're sticking with me here, guys. So here's your probability. 1 minus those 2 numbers multiplied together is 0.0975. You kind of think about that. So you could pick a package of 2 bulbs What's the probability that at least one is defective? Almost 10%. Well, this is not that good, is it? So that's one of the examples for at least one. Let me show you one more and then we're done. For a sales promotion, a manufacturer places winning symbols under the caps of 10% of all Dr. Pepper bottles. So you buy a 6-pack of Dr. Pepper. What is the probability that you win something? The probability that you win. And it says that the manufacturer places the winning symbol under 10 caps. Under the caps of 10% of all bottles. Okay, got my wording wrong there. They put the winning symbol under the caps of 10% of all bottles. The probability that you win something means we're looking for at least one of those to be a winner. So this is a at least one situation, what I've been teaching. At least one. We're looking for the probability of at least one winning symbol, which equals the probability of it equals the 1 minus the probability of no winning symbols for 6 bottles. Again, the probability you're subtracting off is basically the complement. You want to think of it that way. And since we're doing 6 of them, we'll have to multiply that complement times itself 6 times. So here's the math. The probability of at least one winning symbol is 1 minus 0.9 times itself 6 times, or 0.9 to the 6th power, which is 0.4686. That's not too bad. What's the probability that you win something? It's almost 50% when you buy a 6-pack, a six bottle pack of Dr. Pepper, because they put winning symbols under 10% of all the Dr. Peppers. So the more you buy, the better chance you're going to have a winning something. Of course, the more money you spend. But I love this stuff, the at least one thing. It's really kind of opens our eyes to certain probabilities, like picking light bulbs. What's the chances of getting a bad bulb if you're buying a pack of 2? Whew, it's 10%, wow. Or what's the chances of you winning? Well, if you buy more bottles, you get a good chance. Who knows what you win, though. But anyway, that's the deal, guys. The assignment's on Canvas. Here's a stats cartoon for you. Download the worksheet, or else actually a picture of the textbook, and download that and just take your time on it and a separate piece of paper and do the problems. And I'll see you guys soon. Bye.